Welcome. This is session 4.3, X and Y Intercepts. Our goal today is to be able to find X and Y intercepts and be able to figure out what they are. First, let's take a look at our definition. An x-intercept is the point where the line crosses the x-axis. So it's the point where the line crosses the x-axis. And if you see in our example here, you can see this line does cross the x-axis at this point here. That point is 2, 0. So the x-intercept is actually 2, 0. You'll notice that the y value is 0, which will always be the case for an x-intercept. So this y value here will always be 0 for an x-intercept because that's all the points that lie along the x-axis have 0 for y's. Now we'll take a look at our y-intercept. The y-intercept is the exact same thing, except it's the point where the line crosses the y-axis. So if you look at our example here, you can see at this point here is where the line is crossing the y-axis, and that point is 0, 3. So again, what you'll notice is that the x value is 0 in all of the y-intercepts, which will be important when we're finding them algebraically. Okay? Goal tool is just to be able to find the x and y intercepts from a graph. So it's just a matter of finding where that intercept crosses the line. Now, it's not always going to have that, depending on the case. But if you look at number 1, here is our x-intercept. Here is the y-intercept. The x-intercept is 2 spaces to the right, so that is the point 2, 0. The y-intercept is down 1, 2, 3, 4, 5 spaces, so that is 0, negative 5. If you look at example 2, it does not have an x-intercept because at no point does it cross the x-axis. So that's none. The y-intercept is right here. It goes up 1, 2, 3, 4. So that is the point 0, 4. Just a couple more. It's also possible you don't have a y-intercept. Like if you look at number 3, it does have an x-intercept. It does cross the x-axis at negative 3, 0. But the y-intercept, there is none. So here's your x-intercept, negative 3, 0. Y-intercept, because you never crossed the y-axis, there is none. And in 4, you'll notice that the line goes right through the origin, which does connect the x and y-axis. So the intercepts are actually 0, 0 for both cases there. Okay? Now, you could be asked to graph given the intercepts. As long as you have the intercepts, you have 2 points to make your line. So, for example, if I said the x-intercept is negative 4 and the y-intercept is 5, that point is really negative 4, 0 and 0, 5. You can plot those 2 points. And you've just created your line. If I said the x-intercept is 3, that's the point 3, 0. If I say the y-intercept is negative 6, that's the point 0, negative 6. So 3, 0, 0, negative 6. There's your line. Couple more like that. If the x-intercept is negative 1, that's the point negative 1, 0. If the y-intercept is negative 3, that's the point 0, negative 3. If the x-intercept is 7, that's a point 70. If the y-intercept is 2, that's a point 02. And you just connect them. So that's our graphing once we know the intercepts. What could also happen is we could actually have to find the x and y intercepts. To find an x and y intercepts, all you have to do is plug in 0 for the opposite value. So for example, if you want to find the x-intercept, you plug in 0 for the y value in your equation and solve for x. The x value is the x-intercept. So in this example here, I'm going to plug in 0 for y. 2x plus 3 times 0 equals 6. 3 times 0 is 0, so 2x plus 0 equals 6. 2x equals 6. So divide by 2, x equals 3. So that is my x-intercept, which is the point 3, 0. So you'll notice the only thing I did is plug in 0 for y and then treated it like a normal equation. Now, if they give you the same case but ask you to find the y-intercept, you plug in 0 for x and then solve for y. So for example here, this would be 2, 0 for x, plus 3y equals 6. 2 times 0 is 0, plus 3y equals 6. So 3y equals 6. You would divide out the 3, and y would equal 2. So the y-intercept is 0, 2.